Okay, so I'm back, and now we want to go through all of the terrestrial planets and talk about their geological history. So, in the case of the moon, we think that an object the size of Mars, now, of course, it was not Mars, I'm just saying that it had the diameter of Mars, hit the Earth approximately 4.4 billion years ago. So that was only about 100 million years after the formation of the Earth. And so it wasn't a direct hit, because if it had been a direct hit, so here's the Earth, here's this thing about the size of Mars coming in. If it had been a direct hit, material would have been blown into orbit, but it just would have recoalesced as a larger Earth. So what happened was, it was a collision, but it was a glancing blow. So this thing came in and it hit the Earth on the side, blasted some material into orbit, then it went around, and then it came back in for a second hit. So it's called the double whammy theory. And that blasted material into orbit, which eventually coalesced and turned into the moon. But it was so small that it cooled off rapidly, lost any atmosphere that it had, and then without an atmosphere to protect or erode the surface, it's still heavily cratered today from its formation. Okay, now let's lump Mercury and Venus, Earth, and Mars. Let's put them all together here and say that they initially had a molten surface and a secondary atmosphere composed of carbon dioxide and water that came out of volcanoes. Mercury was so small that it solidified rapidly, lost any of its plate tectonics, lost its atmosphere, and was heavily bombarded. So that's what Mercury looks like today. All right, now let's talk about what happened to Earth, Mars, and Venus. So Earth, Mars, and Venus each receive additional water and carbon dioxide from comets and their volcanoes, and all of that water went into the atmosphere, and then it rained back down and formed oceans. So we think that Mars, Earth, and Venus, they each had primitive oceans after they first formed. But in the case of Venus, an object half the size of the Earth hit Venus early in its formation, slowing down and reversing its rotation, or it could have flipped it upside down. It vaporized its oceans and destroyed its atmosphere, but they reformed. Because of its slow rotation, its magnetic field was lost, because you need to have stuff going around in circles in order to make magnetism. So Venus does rotate, but it does it very slowly, and so that would mean that its magnetic field would be very weak. Now, Venus was too close to the sun. Because it was so close to the sun, it was naturally hotter than what Earth was. So its oceans began to evaporate due to temperature. Okay, now once the oceans were gone, then there was no mechanism to remove carbon dioxide. So remember, carbon dioxide mixes with ocean water and turns into limestone. So that takes carbon dioxide out of the atmosphere. So on Venus, what happened was, once its oceans were gone, then that mechanism for removing carbon dioxide was lost. So that meant that the volcanoes, they didn't care. So the volcanoes, they just keep producing carbon dioxide and pumping it into the atmosphere. So the atmosphere gets thicker and thicker, and the greenhouse effect gets more and more pronounced. So the temperature goes up more until finally you have a runaway greenhouse effect. And then we also talked about that it has thicker lithosphere because the plates are not soaked in water the way that they are on Earth, and so that's the reason why it doesn't have plate tectonics the way the Earth does. So now let's talk about Mars. So a object about the size of Pluto hit Mars approximately 4.4 billion years ago, about the same time that Earth got hit. So this was a common occurrence in the early solar system, things running into each other. And this formed the Borealis Basin in the northern hemisphere. And it vaporized the oceans, destroyed the atmosphere, but they soon reformed. But the problem with Mars is its size. Mars was so small that it cooled off rapidly, it lost its plate tectonics, and then that meant that the eruption of its volcanoes decreased. So less volcanoes means less carbon dioxide going into the atmosphere. And also its magnetic field was lost, because as it cools down, then you don't have that liquid iron and nickel in the core that's going around and around in order to produce its magnetic field. Well, that kind of sealed its fate, because the magnetic field protects a planet from the solar wind. The solar wind from the sun blowing on the atmosphere of Mars, it actually blew it away. So the atmosphere thinned, and eventually the oceans began to evaporate. But this time it's not due to temperature. So the oceans started to evaporate because the atmosphere was getting thinner and thinner, which meant that the pressure was getting less and less. And you remember that you can make water boil even at room temperature if the pressure is low enough. Okay, got it? So when you come back, let's do a lesson quiz.